Can you send the link for the Notion doc?
Yeah, within a calendar invite.
Oh, okay.
Okay, where are we starting?
I have one clarifying question. It seems that there is some overlap on the work we have been doing on the Lite client spec, or at least I just misunderstood something. I expected that Zaki will try to cover more the software architecture of the current Lite package, and where we want to go there. And it seems that it looks more like a spec. And then I think that there is, as I think several people also noticed, that then there is a good overlap between what I've been working on and then this ADR. And so is this just my sense, or we are still not considering really the software architecture of the Lite package or re-architecture?
Yeah, that was my understanding as well, that there's really two things. There's kind of three things going on. One is we need proper specification so that we can actually get towards the bisection stuff. One is add a specification inspired interface or API at least for dealing with weak subjectivity into the Lite package. And the final one is re-architecting the Lite package, because there has been some concerns about the actual structure of the code in there and the data types and how they fit together and so on. And so it sounds like Zaki was more so focused on number 2 and a little bit of number 1, whereas we were kind of expecting a little bit more of number 3 to facilitate the review of the PR that's refactoring everything there. So Zaki's not here yet, is he? No. Is he joining? Sorry, I think someone already asked that.
I think it's a little early. I don't know if we end up getting Zaki today.
Yeah. Fair enough. Okay, so maybe we can talk to him. We can talk to him about it after. But so I don't know if there's much to do on the ADR right now. Then, and it seems like we maybe should just continue kind of where we left off last week on the Lite client spec side of things.
Essentially, I think that in terms of sequential verification of headers, there shouldn't be a big question mark. So I think we need to add this distinction between the unbonding period and or bonding period. I don't know how we call it. I'm always confusing this, and this certificate period or trusted period, being called differently. And then we need interface to submit evidence. And so the question I'm having is, like, right now, do we support submitting evidence from like at RPC level, from at the Tendermint level?
Not yet.
Okay.
I'm working on it.
Okay.
You picked that up again?
Yeah.
Awesome.
Okay.
Quick question: does the trust period always equal to unbonding period?
No, it should be some portion of it. I was thinking about
yeah.
But like maybe I don't know, like, what is the good measure there?
But the trust period isn't going to be reflected in the code. Well, it's just reflected in the client code, right? Not the Tendermint node.
Yes.
The protocol doesn't know anything about this trust or certificate period. That's just a concern for the client.
Exactly.
Yes.
Yeah.
Right.
Yeah, it's probably some kind of configuration parameter at a client level, which needs.
If you want to live on the edge, you can make it pretty close to the total unbonding period.
Yeah.
But you probably shouldn't. Yeah. Okay,
exactly. So this is one thing, and the other thing which is not clear for me whether we won't have this as part of the initial spec or not is this consideration of talking with multiple full nodes. How really we want to sort of treat this, because right now we don't have really, as we don't have full membership, we also don't know like how to do kind of random peer selection, which is something which would be kind of cool, because we are sort of assuming that as the Lite client is able to talk at least from time to time to correct node. And so right now in the spec, we don't talk about this because I really don't know how to formalize this right now. And so the question is, do we want to sort of have to treat this at the kind of best effort level at the implementation by saying that you should have always open some number of connection to full nodes, and that you should shuffle this periodically, or we want to try to be more concrete there?
I think best effort is probably okay for now, just so that we don't just to kind of keep the scope of what we're trying to get done more narrow and manageable, and that we might never be satisfied with what we specify around like honest peers or correct peers or so on.
What more could we specify than best effort, given that we don't have any sort of persistent peer identities or civil protection mechanisms for full nodes?
That's exactly the point. So for me, I think that the reason why I haven't added to the spec is exactly because of this, that like we cannot be very formal there. And so right now I think it's at the level of implementation detail, which is sort of, trying to support this in a best effort way, like that you have a peer selection, whatever this means. And so I guess like it would be really good that at the implementation level, we have a mechanism to change or to somehow do a peer selection. And ideally it's behind some interface or something like this, so that we could be able to change this relatively easy if we're able in the future to be more precise there, or we figure out a better way of doing this. But right now, I think like that it should not be one. You should always talk to several peers, and probably we should periodically shuffle. But I don't know if this shuffling or like the way how we send requests should be also constrained by the unbonding period, or it's even not constrained by that. It's kind of orthogonal, and then we somehow hope that the thing will be fine. Because unbonding period is pretty large, so if you put requirement that you should change your peers at least once during unbonding period, or at least change some subset of peers during unbonding period, this is probably not too constraining requirement.
Well, it would be true, I think, that there would be like some changes we could make to the way like client talks to peers, which make it bandwidth inexpensive to quickly check whether a peer might be on a different fork. Like when a Lite client first talks to a peer, it just asks it for the header at the height, its header at the last height the Lite client knows. And if the peer sends back something other than the Lite client's header, it immediately knows that something's wrong. Right.
This could be actually, I think, nice approach, that you are actually talking with the only single full node, and you are synchronizing from a single full node, but then you are periodically doing checks with other full nodes. And so you can say that I'm talking with a full node A, and then I'm assumed that full node A is correct until I discover that he is not. And I'm doing this by talking with other peers, and these other peers I can randomly select in my sort of. And so I think that this is also where we don't have support right now, that this peer selection, we don't have it at a client level way to discover nodes. And so do we have idea how we can support this?
Quick question again. Why do we need to rotate the peers to avoid eclipse attacks?
Exactly. Yeah. So like,
Okay.
Because of
Or to like lower the chance, not to avoid it. Right?
Exactly. So we want to sort of the same thing we are doing also with this punishment. Essentially, we want to put in place mechanism which would discourage people from doing bad stuff, because we can say we can catch you and we can punish you essentially. So like there is no easy way to cheat like clients. And that's why we want to introduce, essentially there are kind of two key mechanisms there. One is that you operate at the trusted period, which is smaller than unbonding period, which gives then the Lite client possibility to essentially detect that something is wrong and then have time to submit it through the network. And the second one is this random peer selection. And this is something which actually let you, because client need to discover that something is wrong. And so regarding the first one, it's just defining a smaller timeout, which seems like a relatively simple thing to do. But the second one is tough, because you want to discover to do a peer selection by not counting on the full node to give you a set of peers, because then you would still be eclipsed. So we somehow either initially we connect to a subset of nodes, and then we ask them to give us a list of peers, and then we keep crawling then through that list, or we figure out something different there. Like, for example, can we assume that the Lite client also connect to seed node? We don't hear.
We could, with the way it's set up right now, the Lite client's expected to communicate over HTTP, and the seed node protocol takes place over the Tendermint peer-to-peer system. So if you want, and so if you just if you just dial the seed node's net info, I guess you'll get some peers out of that, but it's just busy crawling. It won't be the same as asking the seed node for some initial, like for a list of peers. So I don't know. Yeah, I don't know if we want to have like some Lite client peer searching specific functionality at like the seed level or the node level, and maybe expose something through the RPC that facilitates this, versus just having the Lite client kind of try to figure it out itself by parsing everyone's net info and querying people. I'm not sure, but some kind of services to facilitate Lite client peer discovery would probably be valuable, short of having the Lite client just operate at the peer level.
Because the Lite client needs access to the RPC, and our advisory for users is to not run with the RPC exposed, correct?
That's right, yeah.
Yeah. How difficult would it be to get the Lite client to operate at the peer level?
It would be difficult. If we imagine that we want this to be something that exists on phones, for example, written in Swift or something, then you have to write Tendermint peer-to-peer layer stuff for iOS and Swift.
Yeah, so that's annoying. There is talk of, there's ongoing discussion about how to simplify and standardize the peer layer so that it's more accessible in other implementations, which is stuff we need to do anyway. But obviously, HTTP is going to be the most portable thing in the end. But that's not going to work if we tell everyone to turn off their RPC endpoints. So we need some. I guess it means we need to think a little bit more about RPC in the context of the Lite client, and is there really a slim fraction of it that we can that we can tell people is okay to publicly expose? But it goes back to, it's kind of like a product design question on the Tendermint RPC.
I mean, there's always DDoS risk with publicly exposed query endpoints like that, unless they're super cheap. Yeah.
Well, really what we're telling people is it's not don't expose it. It's if you're going to expose it, take precautions and put Nginx in front or something like this, right?
Yeah.
As long as they've got like rate limiting and so on, they should be able to help cover their DDoS risk. So I guess from that perspective, those people can make services available to Lite clients to be able to query through those RPCs.
I mean, there will be RPC services available, and in fact, the Interchain runs one, and I believe AIB runs one as well. Other
Yeah,
folks
but we don't want all the Lite clients just depending on AIB and the foundation, right?
No, we don't.
No,
but we probably
absolutely
do
not.
want them like using specific known identifiers to search for peers.
Right.
If they just use their current peers to search for more peers, we're not getting anything because their current peers control which peers get returned. So,
well, they need some kind of socially validated input at the net address level, I guess, right? So
yeah, and that's like the first input that you have for the Lite client. I was just kind of envisioning that you would pass it the root of trust and then an array of RPC endpoints.
That's interesting. So maybe we make the net address part of the weak subjectivity interface. Is that kind of what you're saying, Jack? Like when you go to get your initial validator set hash from some socially trusted source, you also go to get a set of RPC addresses.
Yeah, that would be nice.
A set of maybe DNS addresses to resolve to IPs. But yeah,
DNS, names exactly. Yeah.
But in that case,
I mean, I would guess that wherever is publishing that root of trust also has an active RPC endpoint that they will allow users to query.
Not necessarily. Well, probably there. I would expect there's more people publishing. Oh, they could publish the root. They might not be hosting their own service, but they could tell you where they query from. Yeah. Sure. Yeah, we can make that.
Yeah. Also, they don't necessarily want to support you as a Lite client, but they can, as you have trust in them, they can also tell you what are the peers you should connect, and so we can assume that there is also trust relationship then being transitively conveyed there. But
yeah, absolutely.
Also, more kind of high level question. So I'm struggling to understand what is the use case, like the first use case for a Lite client, I guess in a context of Cosmos Hub, because this is like, do we know like what
IBC?
What Lite client? IBC?
Well, IBC is the main one we want to get to, and timing wise, it might turn out. But I think we want all the Gaia query commands. I mean, right now there's a lot of altruism in the network, and everyone's relatively trusted. But I think ultimately we want to be able to run the kind of Gaia query stuff with Lite client security, right? Like, say I'm a delegator, and I'm trying to find out how many. I'm trying to like do my due diligence on the validator set and figure out, how much stake different validators have and stuff like this, or, what website they claim to be associated with and so on. All those things are...
There's additional work that needs to be done to enable that, because right now a lot of the SDK queries are going through queriers, which can't return Lite client proofs. So I believe we need the ability to return range proofs as a part of that Lite client proof set.
We already have the range proofs, but the queryers don't abstract over them in any sort of neat way. Yeah.
But that's not fundamental. It's just about like lining everything up, right? Connecting pieces, or is there something?
It's not fundamental in terms of like the proof structure. It is a bit annoying because the serialization format has to be understood by Lite clients. Like if a Lite client is parsing coins, it has to understand how the coins are actually serialized and written to the store. So if
this is like a broader design question about how we can provide Lite client security to clients and what are the trade-offs there. Now, June has an open issue for store accessor types, like i.e. the ability to figure out from a client perspective what's in the store and how to query individual keys. So add that with better Lite client, and then you could wrap the Tendermint RPC interface in a JavaScript library that allows you to kind of do this effectively. That's definitely one architecture. But yeah, anyway.
Yeah, it's a good point that the clients are going to need the schemas for for how everything is encoded.
Oh, we've got the amino encoding and decoding in JavaScript now, so that's nice.
I was going to say, is there any connection between these and web assemblies in the future?
In some magic future world, we'd compile the entire state machine to WASM and clients would just run parts of it when they wanted to.
I mean, I'm trying to be kind of much more sensible, just saying, like, for example, you said, okay, we do it in JavaScript, so maybe just the deserialization could be done that way because we already have some kind of like initial implementation of like amino in Rust. So maybe.
Yeah, I mean, the problem is we have to because the SDK isn't in a position to be compiled down to WASM. Say we really do need schemas for all those types for the clients to be able to serialize them so they can check them. Yeah. So that anyway, that's all work in progress. Yeah. But I mean, to the point of what is the primary use case then, or the main first use case, it could, timing wise, it could turn out to be IBC. Given that, that will all be built into the state machines.
Maybe I was too much of a dreamer. Yeah, that's good.
Yeah.
So can we assume then that we have as part of fixed subjectivity also then some IP address or whatever we want to. Yeah, because for me it seems like that this would be a bit more precise than best effort strategy. So we say you have trust relationship with one node, and then you can ask this node for a set of peers, and then you can maybe keep asking these peers for new peers. And so even if some of those nodes become corrupted over time, then you are hopefully still at least one correct entry to the network. And so maybe for initial, because I'm trying to figure out like what is really like the minimum set of the requirements we can have at a light line level, so we can implement something and then try to use it and then see and develop things from there.
Yeah, I just don't love the idea of having all the peers come from the same source. But short of saying, okay, you have to do your weak subjectivity initialization from multiple sources, or be constantly trying to inject new sources of peers in the life of the client. I don't know what the alternative is.
Well, I mean, making it happen at the P2P layer is actually extremely interesting. But what's the status on that P2P work?
Which P2P work?
Like the sort of standardizing the peer-to-peer layer and making that easier to implement in other languages.
No one is particularly focused on it. I've spoken to the ChainSafe guys a bit about doing a bit more analysis for us on libp2p and what it would look like to integrate that. But I don't know ultimately if libp2p is the right answer, or what is the right answer, or why this problem still isn't solved in 2019. So yeah, I don't know. I mean, we need to like put someone up to the task of like really researching and analyzing this.
Yeah.
Yeah, I asked Daniel.
I think sorry, Zarko. I think Zacky's recent thinking on this is that, like, we should just fix our peer-to-peer layer a bit, especially around Handshake, and then I know that there's some improvements that you guys were planning to make there as well. So maybe that's something once we have some more resources on Tendermint we can tackle.
Yeah, the problem is that it's not. We want something which is supported in multiple languages, and so with libp2p we kind of have this. So
I mean, the truth is, How many languages is libp2p in? It's only in like a couple, right? Go, JavaScript, and Rust, as far as I know.
Different qualities for different implementations. So
Right.
some of them are quite mature, and other ones are
Yeah.
not so.
So I understand the Go and Rust are quite mature. I understand the Rust is actually apparently a lot cleaner. Which
Rust is the most mature. Go is
Most
quite
mature.
mature. JavaScript, I think, is quite mature.
Right. And so, yeah, and that's basically it. And so, for access to the JavaScript one, okay, maybe that's valuable. But given that we actually already have the Tendermint one implemented in Go and Rust, well, they say Haskell and Java and Python are all coming. So I guess that would be pretty valuable. Java will opens up a whole bunch of things.
I mean, that would be fine if it's just JavaScript and yeah.
I'm not sure. I mean, we probably don't have resources for this. So I don't know
For which?
to kind of do this in house to support really properly peer. I mean, it would be super valuable, but I don't see.
What specifically? What piece?
To write multiple peer-to-peer implementations in multiple languages. That's Zarko, you're totally right.
No,
even with a planned expansion, I don't think we're capable.
Well, we have it in Go and Rust. It's a question of it's like classic question of finding people to build it in all the other.
Oh, we do.
Yeah, it's for the KMS.
Oh yeah, that's right.
Yeah. So, if we get someone to implement it in JavaScript, then we'd roughly be on par with what we get from libp2p, but apparently they have implementations in a bunch of other languages underway. And then, so, we could keep doubling down on our thing, but,
Maybe that's something Jordan wants to work on.
Could be, yeah. But I also don't know that it's right. I mean, the Tendermint, first of all, we've had a ton of issues with the man in the middle stuff. So, okay, allegedly there are ways to solve them, but we also don't really have a good versioning story. There are a bunch of other weird things in there that should probably. This was the system was hacked together by Jay in 2014 and never really touched again, right? So maybe sometimes that's actually the best way to do things, but it feels like it could use a bit more thought and apparently that's what's gone into libp2p, but the thing kind of became sort of massive, and I'm not really sure. So anyways, I don't really have a good answer to this.
They had some issue with man in the middle attacks too, and I saw some vulnerabilities with their cryptography.
Exactly.
And in general, yeah, I think that also the specification of libp2p is not complete, and so I think that libp2p is also a big question mark. So apart from the fact that we know that some people are using it, I think that we probably need to define this as a task relatively short term and try really to have a clear answer if this is something we could use, or we need to figure out a way how to improve our P2P layer.
I mean, with that conversation, it just seems like our P2P layer has worked very well for the last few years, and despite the man in the middle issue, functionally it's quite good. Ripping and replacing with libp2p, we would gain versioning and then a library we don't have to maintain.
We would gain a lot more than that. Hold on a second. So XLA is not here, but I think he would probably pipe up right about now because he spent a lot of time in the current Go implementation of P2P for Tendermint. And I think what Ethan said is right, that our current implementation was thrown together and hasn't had a lot of attention and has caused a significant amount of issues. So then the question is going forward, do we want to fix it, or do we want to align ourselves with an ecosystem that has incentives to provide multiple implementations in multiple languages? So for me, when I look at what the prospect is with libp2p, is that we wouldn't be doing it alone. We have lots of other people in the ecosystem that are going to make a Swift implementation, incentivized to. If it's not libp2p, then there's other projects which have the similar incentive structures as software projects. But for where we are today, I don't see any progress without a meaningful design phase that is done in-house by either Ethan, Jay, XLA, or maybe me, before we could even think about contracting it out, or maybe putting a bounty on it, or being like we could resource it with sort of new people. I think there's a lot of tribal knowledge there that needs to get written down and sorted out before we could take a chunk out of this problem.
Yeah, that's a great point, Sean. What is XLA's personal inclination? Because like I know that he is the person to dig into the P2P stuff latest.
Yeah, so we used to meet once a week and did like a little like peer-to-peer working group. We have some notes which I could send around later. That kind of tried to untangle what's currently there. And the main problem, I think we've been talking about this in other dev sessions, is that all of our business logic and domain is also tied up with a peer-to-peer layer. So we can't really rip it out and replace it with something else, because everything Tendermint specific is kind of tied up with like physical connections, specifically the transport type. So
as part of the design phase, we would need to go and figure out where those areas are, abstract them off of their layer.
The cut points. And that means looking at a lot of different reactors, which have been also quite tangled up in a lot of logic. And we made some good progress there in untangling reactors and figuring out how to separate the peer-to-peer stuff from it. But it probably needs maybe a 2-week sprint, I would say, to find out where cutting would have the most value, and then like a whole bunch of discussions with different stakeholders to make sure that everyone's on board with those trade-offs. So it's not impossible. We're not in a complete state of unknowing. There's some good work that's been done there, but we're not at the phase that we could start like smashing on our keyboards and typing this out.
Is that something that anyone on the call has bandwidth for over the next few weeks? Like, probably not, I would imagine.
Something quick I can add is I had a look, as Ethan was saying, in the KMS, there is a part of the peer-to-peer implementation that is working there. And personally, I have found that's not like too good. So there is this open PR that has been there for a long time. There is a lot of progress with testing that. Hopefully, with some work that Thing has been doing, we can like get rid of that like this week. But the secure connection between KMS and the node is something that the money in the middle attack in that case is something kind of critical. So that's something I would say it's important to take into account. And the other thing, maybe someone can correct that, but I think that the current peer-to-peer implementation that we have right now has no reputation, like peer reputation model. And that would help like a lot with the Lite client, I guess.
So guys, we probably table this right now and plan dev session regarding this. But it would be good just to understand, like from the Lite client point of view, how important or how critical is to have some kind of uniform P2P transport support.
So we've got.
It seems that this would give us. It would be kind of very important from the point of view of peer discovery, I guess. Or is there something else?
I mean, my concern is the whole peer system in Tendermint is built around TCP, and that makes sense if you're doing real-time consensus protocol. It doesn't make sense if all you need is peer discovery and you're trying to support, mobile devices in arbitrary environments. And so, I believe that these kinds of architecture decisions were made quite consciously, years ago, with respect to, given that the underlying Tendermint peer system was going to be TCP because of what that can provide and simplify, for building consensus. That the Lite client, the simplest thing to do would be to somehow use the RPC and to facilitate some kind of discovery through the RPC. Now, we never actually got around to doing that. And, in this conversation, we're like, oh, well, why don't we bring the Lite client to the P2P layer? It's not 100% clear that that's right given the current structure of the peer-to-peer layer. If we had, like, we don't even have like a DHT or like a real kind of peer discovery service like that. Whereas if we did, a lot of this would be different. I think those things tend to be more UDP based and are kind of easier to, for low power devices or mobile devices to work with. So
yeah, there's a quick transport for libp2p. The more times we have this conversation, anyway. Okay, cool. That's yeah.
Well, the point I'm trying to make is that we don't even necessarily need to go to the P2P layer for the Lite client. And so,
I absolutely agree.
We need some form of peer discovery. It's not clear that the seed-based peer discovery is actually even the best thing for it, because the seed-based peer discovery is actually currently based on performance as a full node, right? So there's a very rudimentary metric over peer behavior. It's basically, are you a good peer? Are you a verified good peer, or have you not yet been verified as a good peer yet? And if you're a good peer, it's because you've sent us lots of information in the consensus reactor that we haven't seen before over a long period of time. And
correct,
but
maybe
that's kind of useful for a client. Go ahead.
No, I'm saying in a way, like adding, I'm not like advocating for libp2p, but considering some DHT or something like Candelia or something like that would solve all these Eclipse attacks and Siri attacks, and it would be something that would result in a much better Lite client and peer-to-peer infrastructure. I mean,
that's probably right, but I think so. But the point is that it might all be independent of the Tendermint peer-to-peer system, and that's maybe something to think about or consider. Yeah. So kind of in summary, we need some form of peer discovery for the Lite client. On a first take, it could happen through the RPC, but maybe it means we need to design some kind of RPC level peer discovery that goes beyond just like the net info currently exposed, or which might not even be exposed by people who are putting their RPC public. And the other point is maybe it makes sense to have some kind of separate, Kademlia-like service discovery system for Lite clients to discover nodes, especially in the multi-chain context. And, this has already been an issue for people joining testnets and so on. But all of that is going to be basically like a separate design jam conversation, et cetera. Meanwhile, regardless of all of that, we should be able to define some kind of interface at the Lite client level to abstract over all of those architectural decisions and just say, you need to find new peers at this frequency, or you need to have this many peers on initialization, or something like that.
Okay. Good.
Yeah, I think that the upshot of that is like libp2p migration is still on the roadmap.
Yeah.
And there's one more thing which I think it would be good to discuss. It's about this bisection, or in general verification of headers which are not successive or sequential. And so Joseph wrote a formal treatment of this problem, and I have a feeling that we still don't have sort of agreement on whether we sort of want to accept the results there, from that PR, or we want to try to define alternative security model or analysis there.
Yeah, I left a bunch of comments.
Chris, can I just briefly summarize this in 3 sentences so everyone is sort of on the same ground? Because at the end, the model is relatively simple. Does this make sense? So it's really like 3 sentences more or less, and so we can then discuss after. So essentially, what Joseph proposed there is to treat the problem in the following way. Given the trusted header for a duration of unbonding period, which we assume or we trust that at most 1/3 of validators in that header or for that validator set are faulty. But we don't know which are those validators. We just say, given that I trust this validator set at height h, I know that at most 1/3 of them can be faulty. And now, given some validator set at h plus k height, the way how I'm reasoning about this is that now there are potentially new validators in this new validator set, and I don't trust them. because I don't, if I want to do this skip, idea there was to be conservative and say, okay, I don't trust them, so they are sort of assumed to be faulty, or they are part of this kind of faulty set, and then I need to figure out the projection of potential adversary sets in the original validator set and see how much voting power they have in the new validator set. And then if these projected worst case adversary sets set together with the new validators are above the voting power in the new validator set, then we cannot trust that new header, we cannot do skip.
So for just to get some like clarity out of examples, that means like, so say I have a validator set, and then at H plus K, it's the same set plus a few more validators. So because I already had to assume there was 1/3, and now I have to assume I can't trust the new validators, then it means that I can't skip to this validator set.
Yeah, like if there is no change in the voting power of the current validator set, and you add a few more validators in a very high, with a very high chance you cannot trust them. Now there is still a scenario in which you can trust them when you are, for example, just because of the math, the less than 1/3 was still having in the original validator set, there was still space for some faulty validators. And so if you can fill them, there was an example in the Joseph PR where essentially you were like having 6 validators, and like with the 6, you tolerate at most 1. So there is a space for 1 more essentially. So if you add a more validator, you're fine.
Yeah.
So essentially you need to sort of fill. So this is the only scenario in which it's essentially very easy to verify, to compute this stuff. Otherwise, you need to do tricky math where essentially we need to compute what are potential adversary sets, as we don't know who is faulty. And so like if let's say we assume that faulty is process P1, and now P1 is a new validator set, is having 3 times more voting power, then these have very different effect on the trust of the new validator set compared to the fact that, we give the same voting power and that overall voting power hasn't changed much. So this is essentially the more or less kind of the only formal treatment of this problem we figure out up to now. And more or less we are always using unbonding period as a period in which we trust some validator set. So these are essentially kind of two key feature of this thing. And the problem with this, let's say the approach or the protocol, is that it is very very heavy, from the computation point of view. And I was trying these days to figure out if there is a way to sort of shortcut this, at least to have some lucky scenarios. And there are quite some number of them which can tell us that the header is bad. But if you want to figure out that it's a good one, that it seems that at the end you need to do the hard work of computing all. And so so go on, Chris.
I guess I did have an idea for an algorithm that might work, although maybe I sort of misunderstand. I left it in a comment. But independent from that, my concern with this approach is more around the way the security properties are defined. For one, defining it this way doesn't actually capture the single header case, unless you just say that subsequent headers are just trusted, because the state can change by more than 1/3 between 2 headers, and then you would violate the guarantee.
What do you mean the single header case?
Verifying each header in order, 1, 2, 3, 4, 5, 6. Subsequent.
But it does work for that. It does work for that because the current validator set signs the next one, even if it changes 100%.
Yeah, but that's not how this is specified. I would agree with you if it specified that, but it doesn't. It says that like at some height, I trust the current validator set, and I, compute the intersection with the next one, right?
No, but it's only if they're not sequential. If
That's
they're not-
only okay. So you just trust the next header in the case of sequential.
Yeah, because like the point is that if I trust validator set at height h, and they sign new validator set at h+1, I cannot also trust h+1. This is the assumption we were making, and therefore, if I do the sequential header verification, I'm fine. I don't know if this is fine, but this is the assumption we were making. This is.
I think that might not be it might not be explicitly articulated in the spec, and maybe it somehow contradicts the current kind of structure. If you try to reduce k to 1, h to h plus k,
it doesn't work. It doesn't work.
Maybe that's a contradiction. Yeah.
Definitely. So it's not. If you try to reduce k to 1, it doesn't work. So it only.
Right.
So this kind of skipping headers is one, the model, and one protocol, and the other one is for sequential thing. So I don't know if this is good or good, but this is the current state of the stuff.
Yeah. I mean, the other thing, though, is that this doesn't capture the notion of, I don't know, like a necessary fault that we could potentially capture and use to do bisection. I mean, if we want safe bisection, we need to be able to reason about, like, what things the signing of which would have constituted a fault, and assume that those didn't happen, or detect them and report them if they did. And then we can use that assumption to do safe bisection, right? But if we just have this, it's not clear to me that we're going to be able to get what we want in terms of which headers we can bisect when.
And this is exactly the point. This is exactly the discussion I wanted to kind of to trigger, because the current model seems kind of sound from the theoretical point of view, but it seems we cannot really use it because it's so complex to support it. And I'm not even sure, like, Zaki was having some comments, and I was still having issue to understand, and probably has some things in mind. How this, Chris also is now mentioning something I also don't understand, how this approach conflict with potentially some cases we want to catch. Or so maybe, Chris, if you can explain this a bit with maybe some example or a bit more clear, what ideally you would like to have from this bisection, what are the properties? And
yeah, I mean, one preference I would have, or at least idea for an alternative formulation, would be to specify the Lite client algorithm rather as having some trusted set of validators and then like seeing whether it changed. Instead, specify it as doing what a full node would have done. So that if a full node saw some sequence of messages and those messages were condensed into headers, then the Lite client's behavior in accepting or rejecting a particular block should not differ from the full nodes. In some ways, I think that's like a bit more informative because we don't actually use. I mean, the full node doesn't do this, right? The full node doesn't compute intersections of validator sets. I guess if you were using a Lite client to do an initial sync and we wrote this protocol, you might, but.
But the full node also syncs block by block.
Yeah, that's right. But in its checking block by block, the changes to next validator set which were signed over, and there is some, like the full node checks all the state machine changes, so it knows that when validators were added to the validator set, they put up stake, right? But the Lite client also, to some degree, knows that if it trusts a validator set, it also trusts them to run the state machine correctly, I presume. So then if they, sign some sequence of headers, they would have only allowed new validator sets to join if they put up stake. And my point is that I think that provides that gives us more assumptions to work with, because if you consider two headers, like at height k and height k plus n, you want to reason about if you trust the full nodes at height k, is there some sequence of signatures by which it could have progressed to height n, where no one other than those full nodes would have needed to be correct? Or would someone have gotten slashed if you get fooled by being convinced of a block at height n that the canonical chain was not?
But
sorry, that was confusing.
I'm not
My
sure.
point, I think, is useful to capture the sense in which if a full node would have done something given a sequence of messages verifying every block, and a Lite client given a summary of that sequence of messages, or given like another sequence of messages from the same blockchain, would come to a different conclusion, and someone gets slashed. If that's the case, then we can make some assumptions about that not happening if the person getting slashed are validators we previously decided, we trusted by proxy because they were allowed to bond by the validators which we trusted.
So essentially, the way how we can think about this problem in a relatively simple way is that we have two validator sets which are at the heights which are not consecutive one, but there is some gap, and we have trust relationship with the initial validator set. So how we can project this trust relationship to the second validator set, this future validator set, and there, like, we don't have a lot of, unless we sort of expand this problem, we don't have a lot of tools available. So there was this initial proposal was to say that if in the new validator set we have more than 2/3 of voting power of validators which were part of initial validator set, then we are fine. And this was relatively, it was much simpler to support, but so formally this is kind of not sound, because we are assuming that we trust only at most 2/3 of the guys in the initial validator set. So now, So if we cannot now, if those guys are signing, then maybe it's not 2/3 correct. So
and it's also, I'm not sure it's capturing the model of trust that we have. I think the model of trust that we have is contingent upon the validators being bonded, but this doesn't do that. In this case, we would trust, some header 3 weeks or 2 weeks later, less than the unbonding period, with a validator set that intersected by more than 2/3, even though those validators might no longer be bonded. We don't know about what happened in the intermediate.
Yeah, that's why we added unbonding period to the picture, because if we trust validator set at some height h, at some point in time, we know that they were in power because we trust them, and so at least during unbonding period they are still bonded. They might unbond during this period, but at least during this time, in the worst case, we are kind of fine.
Yeah. But I guess, so are you saying that leads to the idea that we should slash validators for signing when they're unbonding? What I would like is to sort of have a Lite client spec that is so clear as to the security properties that we can just derive all of the slashing events from it.
That's exactly what I've said on every one of these calls.
Exactly, but I don't understand what this means. That's the problem, because as you see, the problem, the way how we were treating the problem is exactly like this. You have two validator sets, and now tell me, can I trust the second one if I trust the first one? And so, like, there is, the space is quite constrained. Design space is very limited there. So we can that's kind of the problem. And unless we expand the problem, unless we add something else, we don't have a lot of options here. We can either
the problem isn't just can I trust the other one. It's it's more like how could I be convinced to trust it when I actually shouldn't, when a full node wouldn't have been, which I think is kind of what Chris was getting at, that by having some map to the behavior. By having some map to the behavior of the full node, we can like recover the underlying mechanics, which we actually need to have some relationship with so that we can derive our slashing conditions, right? So the problem with the current approach, while it kind of captures the invariant that we need to satisfy at high level, even understand, can we trust the next validator set? It doesn't quite capture, okay, if we do trust the next validator set, how could we have been fooled into doing that, right? So we kind of need to do both to really cover the whole set of the problem. First of all, like, is there even a world where we can jump ahead and trust this new header that's like, covering the invariance and kind of what we're going on about. And then the second piece is, given that we did go and do that, how could we have been fooled? Right. And I guess they're kind of related depending on, because you could say, okay, well, no matter what, I'm just going to jump ahead and trust it. And then, well, you could have been fooled a million ways and you shouldn't have done it. So there's some kind of constraint on the types of things that are allowed to fool you. It's
right.
like, what is punishable for, basically, right? What can be punished for? So somehow capturing that in the model is going to be important.
Well, or from the divergence, from analyzing what could have caused, what information, where information is some signatures at some blocks, could have caused the Lite client to come to a different conclusion than the full node did.
Right.
Then that information is what gets made slashable. Then we say that,
right.
These are signatures fulfilling some predicate, like if such and such validator signed at this block, then the Lite client would have been convinced by something other than what the full node would have convinced of. Then we slash for that. And that should allow us to derive things like counterfactual slashing, that we should slash validators once they've started unbonding, just from the security model, I think, if we capture it well.
But these things are actually, I think, orthogonal. Because what you're talking about is related with this counterfactual slashing, and this is not necessarily related to the way how we skip headers, because the counterfactual slashing is something we need to support, and I don't think that there are, unless I'm missing something, like you can be fooled by seeing a fork, and so the way to detect a fork is to see two sets of signatures for the same height, which are for a different value. And this is evidence of misbehavior you can send. As you don't have access to anything else apart to pre-commit messages, I don't think we can do more than this. And so if essentially...
Don't think we can do more than what? With respect to what?
I don't think that we're able to catch different faulty behavior than those which are essentially related to the pre-commit messages.
Why? I mean, so far, so how do you think this work relates to counterfactual slashing, and how do we use this to motivate the very fact to derive the fact that we need counterfactual slashing?
So the fact that we don't know how, we don't track the validator set changes, especially if we want to do the skips. Then starting from the validator set, we have trust in during unbonding period. If they create a fork and we detect the fork, we can submit evidence. And I don't see more than this.
Yeah, but what we want to be able to derive is what evidence should be slashable when. We want the Lite client security model to produce like a predicate function on evidence. Right. That says if we want to impose a cost on fooling a Lite client, we must slash for this set of actions, right? And included in that set of actions should be, by that derivation, that if validators who have unbonded or unbonding sign something, they get slashed because that could be used to fool a Lite client. That's what I mean.
Mm-hmm. Yeah, but how this is related with the skipping headers?
I mean, it's certainly related.
That's how you can fool a Lite client. And if you have a Lite client that's trying to skip headers, then a nice way to fool them is to unbond and then sign a header in the future that has all the same validators as the ones that just unbonded.
Yeah.
Okay, I see.
And I guess it depends on, if the model the base model of trust for validators and Lite client security is just that we either trust them or don't, then I suppose just checking the intersections work. But if the model is that we trust them to be rational actors, and as long as they're bonded, follow the protocol, but when they're not bonded, who knows what they'll do? Or if they're not going to be held accountable, who knows what they'll do? Then I don't think we can just use this like single trusted, untrusted dichotomy. We have to reason about when they're bonded and what the penalties are for taking certain actions.
Exactly. Yeah. Yeah. So this is now this is the sort of extending the problem. This simple problem I explained. Now, if you start expanding this problem and say, for example, if you know that the node is bonded, then we have trust in him. Then we can do maybe something more clever there.
Yeah,
But
I think that might be something like what we want.
Yeah, and put even more kind of stress on the time, EFT time, because this probably needs to be, or maybe not.
We should just change that though. It's so easy to make it a minimum of a block height or a time.
No, but so no, I think now I'm starting to understand what you're saying, Chris. So essentially, let's say that I have trust in some validator set at height h, and now at h plus n, if I have information about whether, who is bonded, for example, at that height. But I know this because if they are still present there, I know this. So how could I have this information as a Lite client?
How could you? Well, you don't have information about who's bonded. That's the problem. You just get a new header at height n plus k or whatever, and the new header has some signatures. But it could be the case that the validators who signed the header, you know at the initial header that they were bonded, but it could be the case that they've started unbonding in the intermediary headers and still just send you a signature at header n plus k despite not having been bonded at that time.
So how can we take advantage of this information to sort of derive more clever or more efficient skip protocol? I still don't understand this.
Well, if we define what we are willing to accept as a bisection as any header, the divergence of which with a full node would have caused someone to get slashed, then I think we get pretty strong bisection. We could reason that if we get the same thing the current scheme has, where if we trust 2/3 at the start and we do counterfactual slashing and we get a later header where 2/3 still signed, then we can utilize that knowledge to know that if they had been unbonding and signed the header anyways, they would get slashed. So we assume that they won't do that, and we trust that.
So it's actually not clear to me if this stuff is going to simplify the bisection calculation, or if it's something that comes on top. It sounds like it's possible it could go either way. I don't know yet. I don't know, Chris, if you have intuition there, but
sorry, which stuff are you referring to now? Like the
evidence, like the kinds of things we have slashed for, these evidence predicates.
But do you see any evidence predicate apart from the fork? Do we care about if we see, for example, that we have equivocation at the Lite client level?
So far we've hit on three distinct types of evidence, and each one was kind of emerged in a discussion and created concerns. They're like, oh, why weren't we thinking about that already, right? So maybe there's some that are even still missing. So, but they're basically okay, you explicitly double signed. So you signed for the same height for two different blocks, or you recently unbonded but continued to sign. In which case, you and the people that unbonded may be able to convince a Lite client that, in all cases, they count as constructions of a fork, but we're basically trying to punish the behavior that would lead to the fork rather than just the emergence of the fork itself, right?
Yeah, sorry. To go back a step, I mean, the difference between the model where you reason about the difference between the light client and a full node is that you get bisection when the change is like less than a third, right? So it should be different from the set intersection thing, I think.
Because this evidence thing, I think, holds exactly the same also in the model where you're verifying all headers. You have exactly two.
But in the model where you're verifying all headers, as far as we understand, you only need the unbonded. You know, if people unbond and sign something else,
you know that they're not bonded anymore, so
it's
just
not an
ignore
issue. Yeah, because exactly, they can't fool you, right? So the counterfactual slashing isn't an issue. Though I thought Jay, for some reason, somehow concocted a scenario where he was saying it still is.
Yeah, but like the fact that you are verifying all headers doesn't change anything from the client point of view, because the client, I see.
It does, because you know exactly what the next validator set is. So
Yes.
if a validator unbonds, and then you know what the next validator set is, and it doesn't include them, they can't then pretend to send you a signature at a higher height.
Okay, I see.
Right? Because you know they're no longer part of the validator set, right? You can't be fooled.
Okay, I see. So yeah, this is very important. So so essentially, if there are more than 2/3 of faulty validators, then in that case you could have a fork, and so you have this. If you're verifying all headers, then you can actually track this, and with the skip. Okay, I see. Okay, this is important.
That's right. So you need 1/3 intersection or something like that instead of 2/3.
Okay, I see. Yeah, this is important distinction. Okay, now I see. Good. So in case of skips, we don't know how the validator sets are being changed, and therefore this bonding, unbonding, who bonded, who is not, give possibility. But now, do we make a difference between the fact that some validator withdraw, so he is during the unbonding period, but he is not bonded at that point in time, and some other validator who is still in power? Because during unbonding period, if they double sign or do whatever, if they misbehave, they would be punished. So why we want to sort of emphasize this difference?
Well, because they're different kinds of evidence. They're detected differently, right? In one case, you're talking about someone produced 2 signatures on conflicting messages. In another case, someone produced a single signature when they weren't supposed to.
Yeah, you're right.
And I think the third case had to do with invalid state transition. So it's only a single signature, but on an invalid next validator set. Okay,
yeah. So I think I'm starting slowly to get it now. So there are actually more evidences than you're right than just forks, because in the case where the guy withdraw and he's not bonded anymore, we don't have equivocation. So we have actually one set of signatures and another set of signatures, and so there might be completely different set of.
That's right.
Right. Exactly.
That's right.
I mean,
so there's no double signing. Yeah.
It's still all about forks. It's just not necessarily double signing.
Yeah, but so this is somehow different. And so the question is, so what Chris, you are saying is that ideally we somehow want to capture this, and this might even simplify or be used as part of the skip procedure.
Yeah, I think so. Because if we write sort of light client protocol relative to full node protocol, we should get a definition for what specific signatures would cause a light client to diverge from what a full node would have done. And then we can use those to determine what costs we can impose, and we can determine what costs we can impose to make choices about when it's reasonable to do certain kinds of bisection.
But they somehow assume that you as a light client, you have a connection to the main chain, to some full node who is still connected to the full chain. Otherwise, how you can make this distinction?
That's right. That's the whole thing we were talking about with peer selection. You need at least one good peer.
Assume. Well, no. I mean, it assumes that you will be able to submit evidence eventually.
Yeah.
So, in that sense, yes.
Well, but you have to even know that you have valid evidence. Like, you're not going to know there's evidence unless you have access to the chain.
As to know that you have. I see. Yes.
I mean, you could just be.
Although I would say, but only
everything all the time. But
yeah, but only in expectation. Like we're sort of talking about the calculation on behalf of a rational full node is deciding whether or not to double sign or to sign when they were unbonding. And so they're going to say, what's the chance a Lite client can report this, right? And maybe it's not 0 or 1. It's something in the middle. That's going to make things more complex, but in real life, it is like that.
Yeah, but somehow the fact that if you're unbonded and you are signing, you keep signing, and you create a fork, then is there any difference with respect to this and the fact that you double sign on the main chain? Like, what would?
Yeah, I mean, the full nodes don't care. At the moment, we don't even punish for this. You could just do it.
Exactly.
There's no punishment at all because the full nodes aren't going to get fooled because they're running the state machine, and they'll say, "Well, you're not in the validator set." They won't even look for your signature. But the Lite clients, who, I mean, this all came about by starting to design bisection. Then we realized that we had this problem, right?
Mm-hmm.
Because the Lite clients don't know that. And at the moment, the third case, which Bucky mentioned, invalid state transitions, we don't deal with it at all. I mean, if rational validators might sign an invalid next validator set hash, there's no detection or punishment for that at the moment. So I don't know if we want that or need that, but we don't have it.
Yeah, so Anton is asking whether we can go with a simple model. Yeah, definitely. Sequential verification, I think that we don't have a big question mark there. Also, if validator set hasn't changed, I think that we are fine.
But we don't know if it's changed. Even in the case when it's exactly the same, we still need to do counterfactual slashing because the Lite client doesn't know if the second header they're getting.
Exactly. So yeah, I'm assuming that we have counterfactual slashing, and so
Okay.
I'm assuming that the Lite client is talking with a set of peers that we somehow have through this best effort possibility to from time to time talk with at least single correct full node and have information about what is happening on the main chain, and we can detect the misbehavior and have a API to submit evidence. I'm assuming that we have this, and with the sequential verification, I think that we don't have a big question mark there. So the discussion was, I think, more about what we do, what is kind of missing to also support bisection, because I think bisection was kind of the killer feature here. If you don't have the bisection, then I don't know how light this would be.
Right. Thanks.
Well, and in particular, I think in practice we need bisection under small but non-zero validator set changes. That's going to happen most of the time. That if you wait a week, the validator set will have changed a little, but not a lot. And if we come up with a bisection algorithm that deals quite well, quite efficiently with the case of a little but not a lot of change, in practice that will be efficient for like the majority of
that's the problem, that this current approach we figure out with Joseph, like even if you have a small set of if you have a little validator change, it might end up being super costly to verify, because depending on in which case we are, we need to compute potential adversaries, and so this is super expensive. So the fact that you added one validator or you added 3 of them doesn't help a lot. In a positive case, like in a negative case, there is a bunch of, so I kind of compiled a list of negative cases, which relatively fast can tell you cannot skip, you need to try with a smaller header. But in case you really want to verify the header in a positive case, you need to, right now, this is current understanding, you need to compute these potential adversaries, and this can be pretty tricky. because we have a distribution which is with a lot of validators with a small stake. And so you can have quite some number of them creating. So is it clear for everyone what is potential adversary set? So this is like any combination of validators, which in total are at most 1/3 of voting power. So any such set can potentially create us problem in this key protocol, because we need to compute all those sets and project what is their voting power in a new validator set. And then
yeah, but is there something we could do that is a bit like more efficient? Like, what if we just take the intersection between the keys of the old validator set and the new validator set, figure out the total stake of the intersecting keys, subtract the largest first validators, like assume the largest stake faulty nodes intersected until we reach 1/3 or just below 1/3, and then check if the resulting total is at least 2/3 of stake. The total that now we know that we still trust is 2/3 of stake at the new header.
So you can try. So I was trying 2 days to simplify it, but it always boils down to the same thing. Like in a positive case, in a case you actually can skip, I don't see how we can shortcut except calculating really all potential adversary sets.
I also tried a few optimization, Chris, and I put a note in the issue there. And with the, I tried on the Cosmos Hub validator set and tried a different optimization, but you always find some subset that's 1/3 minus 1.
Mm-hmm.
So therefore, at least one, I mean, there may be many. So if the power changes just by 1, you're over the 1/3.
Yeah.
With 20 validators, the story is different. It's a bit better. But with the 100 and the way the power is distributed, it's not. So
That's the thing. So that's why I'm wondering, like, if there is an alternative way to think about security, which is still meaningful, more practical. Because the current one is complex, and also it's very pessimistic. So I don't think that we'll be able to skip very frequently.
Oh, I see. You're right. I misread this the time I looked at the spec. I recall having Anka's reaction when we discussed this a month ago or something. Yes, right. You're right. If it changes by a tiny bit, and there's a pretty wide distribution of powers, there's always going to be like some pessimistically chosen group who could now be.
One thing I haven't tried is to sort of try to constrain the validator set changes, and then to see if maybe we can take advantage on this to simplify the reasoning. But I don't have intuition how this would help. For example,
sorry, could you repeat, Zarko? I missed.
Yeah, like for example, we somehow constrain, because initially we assumed that we cannot have more than 1/3 of validator set changes, and we were having intuition that this would help. But right now, I don't see any sort of intuition how constraining the validator set changes could help us with the skip protocol.
Well, for instance, if you don't let the validators change, you only let the changes happen in every 10,000 blocks, then you can skip, 9,999 blocks.
Yeah, this is probably the only way. Mm-hmm. Then the verification is very simple. You just check whether you are within unbonding period, and you can jump. Mm-hmm. But if you have changes in every height, then we might be in trouble. Mm-hmm.
Yeah.
So one thing that could help, I mean, we discussed this with Zarko a couple of months ago when Joseph started to write this. And I asked again, and I'm going to ask again, is there any way we can actually, from the trust side, we know we trust 2/3 of the power. Is there any way to actually pinpoint the trusted? I mean, well, for example, at the time I brought this up and Zarko said, no, but something similar along these lines. If you see a signature, can you trust the validator that signed that? Somehow, right? Not just by reading it in the header, but somehow getting it from some kind of.
Yeah, Anka was assuming that,
yeah, I was naively assuming, if I see validator 1, 2, 3 signing this, maybe I can trust him and the voting power associated with those validators. Therefore, it's easier to do the math. I mean, it's, but yeah. And the other question is, the same way you get a trusted header at head H, can you also get a trusted header at close to H plus K? After you do that, just a sequential, something simple where you just always have available a trusted header close to the one you actually want to sync to. So,
I mean, the whole point is that you only have to do the weak subjectivity initialization if you're offline longer than the unbonding period.
Right.
And so the idea is that the unbonding period is that kind of short window. But I think, with the number of blocks we produce, doing, verifying every header is still going to be a lot over 3 weeks.
Yeah. I mean, I think maybe this model is just stronger than what we need, because this does, I think, reject some situations when a full node when there could never have been divergence between a full node and a Lite client anyway. Like if the stake has changed just a tiny bit between height K and height K plus N, but the tiny bit does mean that some like maximal subset, which was chosen to take advantage of that tiny bit, could now be more than a third. That doesn't mean that they could necessarily have convinced a full node of another block than they'll be able to convince the Lite client of. I don't think there's a
so this is probably
there.
like, I think what we can try to do is to more or less try to weaken the model to say, for example, what is in the worst case, what happens if instead of assuming that we trust more than 2/3, we somehow trust the whole validator set at height H. And now, if we have a subset of this guy in a new validator set, and they are large enough, so they are more than 2/3 of validator sets, how this could, what is the worst case in terms of the state, the Lite client can be tricked about. And so maybe this could give us still some sense of how we can sort of weaken this model, but still have something meaningful. Because
but how does that work? You trust 100% of it at height H, then you jump to where, and you say, if the power change is less than 1/3, then I trust the header at H plus K. But then if you want to jump again, it doesn't work anymore. You're back to the same problem.
Yeah, right.
No, the question is like, if I trust more than 2/3 at height H and at H plus K, I have, let's say, more than 1/3 of correct guys, can I still trust? And they are signing something, can I still trust this? So this is essentially like, I think, the alternative approach. So and this is, I think,
why do we need it to be stronger than the full node equivalence model? I mean, if the Lite client trusts something a full node would have trusted, or like that there existed a valid sequence of messages from a full node which have gotten to it, but that thing doesn't satisfy this criteria, I guess I just don't see why we care. Like,
I'm with Chris.
why would we want Lite clients to be more secure than full nodes? or like make stricter assumptions, what does it give us?
Yeah, it seems like I think actually that's right, and then maybe the way to weaken the model is by looking at is there evidence? Is there so you can jump ahead if it's possible to construct evidence to punish someone for fooling you.
That's right. Exactly. Yeah.
Yeah, and that's kind of what's missing from the model currently, and something that we could try to figure out how to factor in, and that might simplify somehow the calculation because it gives us more info.
Exactly. And I think that, for example, one way to reason about this is to say, like in this initial proposer, if I see that all validators have more than 2/3 in the new validator set of voting power, then probably this gives me at least some number of correct guys there. And if they're assigning something, then I can either trust this or I can create a proof of misbehavior.
Right.
Something like this.
Right, exactly.
Yeah. And this ideally would also kind of be more aligned with like what you were saying about the fact that Lite client protocol give us the evidence.
Right.
Evidences for, Okay. Yeah, I think this is something definitely we can try. And I also talked with Joseph about this, so he is back on Monday, and he said that he would like to continue working on this, and so we can try to see what are alternatives, because the current one seems like secure, but too strong. That basically we cannot use it. Because I think that our intuition we want to capture is that if we have a small change in the validator set, we somehow want to trust this. Like,
I'm sorry, but I missed. What's the extra information that would go into Joseph's?
No, it's not necessarily extra information. It's just that we are assuming weaker thing when we do.
Which part is weaker?
Weak is essentially like, and this is something which we normally also do in this kind of protocol, that if you see that at least one correct guy is doing something, you can trust this. And so
but we don't know which one is correct, right? That was the
no, but specifically the thing here is that it's possible that you shouldn't have jumped, but if you did, you'd be able to produce some evidence that punishes someone. Because right now the model is set up so that it's just kind of binary. It's like either it's safe to jump because of the 2/3, trusted, or it's not safe. And so what we're weakening it to is to extend the acceptability into that non-safe domain somewhat, so long as you can get the people punished that fooled you. So it's okay to jump to an unsafe header so long as you can produce evidence that.
And I would.
But how can a Lite client produce evidence with just the header information? I'm not sure I understand.
It will send the header. Yeah, it has the signatures. It can send the header to a full node. It needs to be able to reach a full node within some time bound, but it can send the header to a full node, which can report it as double signature evidence or evidence of signing when they ought to have signed.
Okay.
I mean, another thing I would note, not to add more complexity, but to add a little bit more complexity, is that it should be possible for Lite clients to choose stricter requirements for bisection if they want, like requiring 4/5 instead of 2/3.
Okay,
that's interesting.
And
stricter or less strict?
Stricter. So in the model where we're reasoning about, a Lite client will accept a header as long as it's the case that if they had been fooled, someone will get slashed. The Lite client can also be stricter about like how many people will get slashed and what the cost of the slashing will be, and like how many double signatures had to occur, right? Does that make sense? The Lite client can say, like, here are all these situations. And in these situations, this is the signatures that would have had to occur for me to diverge from the full node. And given those situations, like I'm okay with some of them, but I'm not okay with others. So I will construct my verification such that it does the skip thing in the case when the evidence, which I think is, dissuading enough, would be produced, but it doesn't do it in the other cases.
Yeah, so I think that also one way maybe to kind of capture this thing is also to have more to have trust at a validator level. So not a set level, but you say, these are the validators I trust kind of more, and so if they are present in a new validator set, I'm fine.
I would be very, very reluctant to add that feature. That adds and pushes a lot of complexity onto the users and starts to make this like client thing. Basically, you have to know and understand a lot about a validator set in order to connect to it with a like client, and I don't think that's the model we're looking for.
Yeah, this is like the really like how to say the completely opposite direction, but like this is like the one side of the spectrum of the design. But I see more realistic something to say. For example, if I see more than 1/3 of voting power from the trusted set, then that's fine. And I don't care, how much they are, how much they constitute there. If they sign this, I'm somehow fine to go with it.
Yeah, but so here's the problem. If in the case of the hub, you would have to like understand which hub validators you trust and then add those to a whitelist.
No. I'm saying that this would be the proposal would be not to count particular one. This is just the general case, let's say. It's just that counting the number of voting power. So you look at the trusted validator set, you look at a new one and say, if in the new one I have more than 1/3 from the initial one, then I can trust it.
Like in making that 1/3 number configurable. So maybe you would have it up at 2/3, or as Chris was saying, three quarters or something like that.
Yeah.
That seems to be an easy change. Just like when we're doing the check on the bisection tries, we would just check against a configurable number, right?
But we need to do the work of essentially clarifying the rationale behind each of those options and what are the risks and what are hopefully the evidences which we can detect in those cases so that it's kind of clear what they mean. And I'm still not fully convinced that we can do this, but I think that at least we can try to somehow model these different options and see what are the security guarantees we could have out of these different options.
I think there's obviously like 1/3, then 2/3. Those are the kind of obvious ones.
Exactly. Yeah.
And
that's
then
why
beyond that, then like if you wanted it, let's say 90%, that just makes your bisection slower at the potential benefit of catching some of these weird corner cases.
Yeah, I'm not quite. What exactly do you mean, Zarko? Do you mean that you think it's possible that a weaker model might not exist, or that we'll just have trouble articulating it? Or I'm confident it exists, right? Like the folder protocol specified.
Okay. Exactly. So it definitely exists. I'm not sure really, whether we can come up with some kind of sound guarantees in that model.
I see.
But I think it definitely exists.
But Zarko, just quick question: the current implementation doesn't have this weaker model where we trust all the validators that sign the trust letter.
It has this,
right?
Or it has this. It can be interpreted as the fact that we trust the complete set, or the fact that we are fine with more than 1/3 projected in a new validator set. So
I'm also curious, maybe at some point discuss this, or maybe it's a very short answer. evidence submitted from the client, how is that verified?
Verified by a full node?
Yes.
They check the signature. They basically load the validator set from the height that the evidence is from, and they see if it's from a validator at that height, and then they check the signature. And then, so if it's
can you fake something like this?
Sorry, it's a little more complicated than that because it depends on the type of evidence. So if it's double signing, then you say, okay, if this is a validator that was actually a validator at this height, and they've provided two signatures here, and the signatures are on different blocks, then that's valid evidence, and we punish the validator. And assuming the signature construction and the hash construction are secure, no, you can't forge that. The other one would be if you were a validator and you're no longer a validator, but you're still in the unbonding period, and you have produced a signature on a block, or maybe just any signature that is valid, then actually we have to double check that, because I think you can produce valid signatures on garbage messages. So we would need the verification to be strict enough that it actually checks that the message was like a real block or something. So yeah, sorry, does that answer the question? I mean, there are some subtleties around forgery, but if you're precise enough, it's fine.
Mm-hmm. Okay.
But normally the way how client verify that something is wrong, it should be more or less the same, because you need to see a set of signatures which are not matching, and so this is already kind of a proof of misbehavior. And then what the validator need to do in addition is to just figure out where is the guy I need to punish and who is the guy I want to punish.
Mm-hmm.
But you have two sets of signatures which are for different value, and this is evidence, I think. And so verifying this should be easy.
Okay. Sorry for the interruption. You were
no. This is good.
Great question. Yeah.
No, I was also thinking about this, but I somehow realized that if you're submitting evidence, it's not like I'm submitting something which seems like evidence. If you submit something, it should be evidence. So you should have two sets of signatures for the same height for a different value. Or at least like you could have the two sets of signatures for the same value, but the same validator have different signatures, as part of this set.
We actually don't punish for that right now because that can't be used to fool anyone, as far as I know.
Okay, so then essentially it's like it's a fork. So we need to detect the
You
fork.
just have to have, it's only if they're signing for a different value.
Yeah.
But that's just for the equivocation. There's also the counterfactual one, which is a little bit harder to detect because you don't just have two signatures. You have one signature and somehow the knowledge that the person is no longer in the validator set, but recently was.
But how you detected a client? This like you download the header and then you see the header has changed and then you submit.
Yeah.
I don't know exactly how you detect it as the client. You basically have to be checking. When you're doing this bisection thing, you have to be querying the validator set at other heights at the height that you're getting signatures from other nodes to find out, are these actually valid validators? So there has to be some frequency by which you're requesting information from other nodes to find out if what you're seeing, it can be corroborated.
Yeah. What I assume that in that case, let's say that you query some other peer for the header, you have confidence in, and then you see there is a different header. So then you can follow up by asking, give me validator set, which signed that header. And then now you have signatures. And now these signatures you can compare with the signatures you have. And this is evidence. Because they are, they must be conflicting. Because or maybe not.
So I have a very naive question. We're talking about the node we're trusting. Why don't we get the headers from that node we're trusting?
What do you mean a node we're trusting?
Well, we're talking about the client asking correctness things from a node that the client trusts.
You mean for the initialization?
For this, and there were other mentioning during this talk about verifying things with a trusted node.
Well, okay, so basically the trust, I think the trust model that we want is something like the following. So initialization requires a highly trusted, socially validated node. You require that once. And then so long as you continue to be online on the duration of the unbonding period, you no longer require such a singular trusted node. Right. You can use a generally untrusted network under the assumption that you can reach a correct node, within some amount of time. You don't know which of those nodes is going to be correct. So for the initialization, you assume you were able to identify a correct node, singular node, point to its ID, say this is correct, right. Socially validate it, initialize your thing, right? From that point forward, so long as you don't go offline for too long, you should be able to, operate as if you don't know which nodes are trusted, but you have the assumption that you'll be able to find at least one correct one. That's kind of the model of the peer network that I think we're working with.
Okay, so just real quick, this is a great Lite client discussion. A lot of excellent points touched on here. What are next steps?
I guess we go back to the spec and see if we can integrate this full node behavior component to see if we can slightly weaken the model to accept bisection jumps for which we could generate evidence. And see if that, if that changes, that simplifies the computation here and gives us a way to derive the actual types of evidence that we need to slash for. I mean, that's the dream.
Can we proceed this in parallel with the implementation of the sequential verification?
I believe so.
Yeah, that seems to be easy. So just so I'm understanding, this sounds actually a bit more complicated. This sounds like Lite clients are now submitting evidence.
That
always had to be true.
Okay.
It just wasn't happening, but it all.
It was never implemented, but it was always theoretically true.
Now I might have missed this. Did we discuss Zaki's proposal in this call as well, or is that sort of orthogonal, or a subset of Zarko's proposal?
Well, so we talked about it at the beginning that basically three things going on the Lite client front. One is getting a real, which is kind of what we've been talking about for 2 hours and what Zarko's been working on. One is capturing the weak subjectivity realization in an API, in an interface to actually be used. And so part of that is what Zaki had written about, and part of it, what he written about, was the spec. And the third thing, which we were kind of, I think, expecting from the ADR, was a description of the state of architecture of the Lite client package, kind of somewhat independent of the spec stuff. It's actually talking about code architecture and kind of why it needed to be changed, or what the direction to go in was from a code architecture perspective. And it seems like that isn't really part of that ADR. And it's, given that there's a huge pull request to dramatically refactor that package, it would be valuable to kind of, at a high level, understand the design of the package kind of independent of the spec. But it seems like that doesn't exist yet.
Okay, so it sounds like we need refactor rationale for that PR that's live right now that Anton's on.
Yes.
Okay.
We still don't have API for counterfactual slashing.
For submitting evidence, or what?
Yeah.
Well, I think that's what Anton was working on. Submitting, having a broadcast evidence endpoint.
Yeah, we also need an evidence reactor in the SDK, I believe, as well. Which is something that...
What do you mean?
We have it. This is at a Tendermint level. So Tendermint is have evidence reactor, and then we just forward it to the state machine.
Oh, I mean, either of them works.
That's for
if we do it at the Tendermint. At one point, I was discussing with Bez doing the whole thing in the SDK, so we'd avoid requiring any changes in Tendermint. But if we can do it at the Tendermint layer and just pass it through ABCI, it's probably better.
Yeah.
Oh, okay. So, Chris, my understanding was that we were going to do this at the SDK layer.
I mean, specifically, I was talking with Bez about the case of counterfactual slashing. When I think the SDK already has all the relevant information, it knows what the unbonding validators are, and it can verify that they signed something. I guess it would need to check that it's the right Tendermint header type and stuff. So that could be done in the SDK, but it could also just as easily be done in Tendermint and then forwarded through ABCI.
Right.
And it's a bit more.
It might be more work in Tendermint. It probably belongs in Tendermint, but it will require a bunch of work because we don't currently track who is unbonding. We just know the current validators and previous validators.
Right.
So, right. That might be a bit.
So I guess it's a question for Anton as to how much work that is.
Right.
And so maybe do we sort of agree that regarding sequential verification, we don't have a big question mark there?
I think so.
So can we say that the next steps could be that on the Go version, we need essentially to do refactor or at least have ADR about how to really.
Yeah, and we need to ensure that the implementation actually is secure, even for single header verification. For example, at the moment, I'm not sure we check next file set hash in all the places when we ought to. That sort of thing.
Yeah, that's the thing. So I think that we can maybe as a next step, just so that we kind of keep going in the direction of having some Lite client implementation, we can do probably two things. We can do refactoring or at least some kind of rationale about the structure of the Go Lite package, and then we can hopefully start working on Lite client in Rust for sequential verification.
Yeah. So what's very important is the Go implementation and ensuring that the chains that we have a way to connect via IBC. So, that's definitely the first priority. The Rust stuff, that's a different. I believe this call is specifically to discuss the Go implementation, but I could be wrong.
No, I'm just thinking it's just to understand what are the next steps, because I think
Pardon,
this call was mostly about the spec rather than any implementation.
Yeah, absolutely.
No, I'm just wondering, having implementation also, at least some simple implementation in place might also help us, because I think we are also missing this kind of feedback from the engineering side.
Well, I'm looking forward to trying to put together a relayer as soon as we have this. So,
Okay. And we'll continue this work on trying to come up with a different model, so which would hopefully make this section possible. And so we'll work on this also next week with Joseph and also who else wants to contribute to this. So we are kind of continuing on this,
Cool. Yeah, I'd be glad to join the call whenever Joseph joins. Joseph, I think that'd be helpful.
Yes, we'll try. I will. So we have this recorded. Perfect. So then Joseph I will ask him to catch up with what we discussed, and then we can try to follow up for Monday. So we have a meeting scheduled. So I can invite you, Chris, for Monday, so that we try to explain the context also to Joseph in addition to this, and maybe to try to come up with some plan how we want to address this and what are the models we want to consider.
Sounds good.
Okay. Cool.
Good stuff. Okay. I guess that's it for today. So I'm going to stop the recording.